this next session of LC University. Today we're going to be covering metering technology and applications, as well as PD meters. Before we get into it, I just want to cover a few things. One is you should have received either if you signed up earlier on in the sessions, you should have received an email, or if you've just recently signed up and enrolled in the course, an automatic generated email with some course information and also the invite to the portal, which is where you can view the videos. So we've had a lot of questions from people asking where they can view and see the videos. So real quickly, I'll just share my screen. So if I share my screen, you should have received some sort of email similar to what you're seeing here. It has, how to download the Teams application, which we'd recommend you always take these courses with the Teams application on. You get a little bit more features like the chat and the closed captioning. But on there also should have been a link for the LC University video portal registration. So if you click on that, that's going to automatically open up, go to our website, and you'll be able to sign up for the portal. Once you're on the portal and it downloads, for some reason it's going really slow today. Once it downloads, you'll see the list of all the courses. And man, it's not loading. Anyways, if it loads here, there we go. You'll see the list of courses on the screen after you've registered, and you can see all the different classes that are coming up here and the dates that they're going to be. But the classes that have passed, once the videos are posted, you'll see that there is now a link here to where you can click on that, and that will take you automatically to the private YouTube page where you can watch the previous videos that have gone on in previous classes. So again, a little bit of work in progress here, but we finally got that up and running. Thanks to Dan Clevenger's hard work here in getting that prepared. So I imagine within the next couple days, the class that we're doing today will be up there, and so on and so forth. As far as upcoming classes, this month, we're lucky to have our regional managers here that are doing some presenting here for this week's class and also the class in 2 weeks. So again, today's class is on LC metering, technology applications, and positive displacement meters. And then next week, they're going to come in and do a quick class on an introduction to our electronic registration. So that's going to be LCR2, LCR 600, LCR IQ, and Master Load IQ. And then after that, when we get into June, it'll be back to more technical with the technical service team, where we'll do a deeper dive into the LCR2, go through installation, troubleshooting, and basic setup. And then followed by the last week of June there, June 23rd, we'll be doing mechanical registration, calibration, gear plate selection, and then calibration for electronic registration. So I know there's been a lot of people asking for some calibration training, so that will be a class you'll surely want to see if that's one of the things you're looking to do. All right, so let me stop sharing that. All right. So a couple other things. Remember that if you want to ask some questions, we will be kind of pausing in between, and then also at the end, we'll hold some time to address any questions that anybody has. So if you do have questions, please feel free to unmute yourself at that time. Otherwise, we ask that you remain muted so as to not distract the presenters while we're presenting. But once there's a break, if we ask for questions, please feel free to unmute, ask your questions. Also, there is a little chat bubble at the top of your Teams screen. If you have the Teams application, feel free to chat a message to us. The people that are not presenting at this time will try and address those questions as they arise, or we'll break to ask the presenter those questions as we go. With that being said, I'm done talking. We're going to hand this off to our regional managers. So today we have three of our finest here, Dan Campion, Kevin Nugent, and Rick Hembry, who combined, I just learned, have a total of 88 years of experience with liquid controls. So I think you'll be in good hands here today. And I enjoy, again, if you have any questions, concerns, Ideas for the classes, don't hesitate to contact myself, Jeff Hageman, that's me, or Dan Clevenger, and we'll address those as best we can. And with that, I'm going to hand this off to you, Dan, if you want to go ahead and take control. I'm going to exit the spotlight mode, and it's all yours. And you'll need to unmute.
Have I muted?
I can hear you.
Good. I'm going to go share screen. And this one. Okay, I just want to double check. Are you able to see the screen that I'm presenting?
It's not up yet, Dan.
Because it says at the top that I'm presenting.
But you're presenting, but did you share your screen?
Dan, I would unshare. It looks like you shared the Teams screen. Go ahead and unshare.
Yeah, maybe, yeah.
Yeah, hit select and then pick. You should be able to see the presentation as one of the options to present.
It says that my shared screen's paused. Spotlight me.
Yeah, Dan, you don't want to spotlight yourself. So if you go up to the little screen with there, that's you. You've just spotlighted yourself. But if you go up to the share, right next to the leave button, there's a little square with an arrow in it. If you click on that, and then you'll want to select the window down below with your PowerPoint presentation.
It's clicking on it. It's not coming up.
It's up now, Dan. So go ahead. Now it just disappeared.
Now? Hide shared screen? No. I don't know what to say.
You me try doing it to see if I can do it.
If you could, Rick. There you go, Rick. If you could then just hit the presenter, the little full screen. Or the play, you know.
I'm flying blind here, guys. Sorry.
Can you see Rick's screen, Dan?
No, I cannot. I can see a gallery.
I can see the screen. Oh, we had it.
We had it, but he just.
Hey, Dan, go ahead and try sharing your screen again, and then I'm going to request control, and then I can go in and select it for you.
Okay. I'm sharing the screen, but once I point on the screen that I want to show, it's not coming up.
Okay.
Let me leave the.
Yeah, leave it there, Rick. Rick, hold on a second. There we go. You got it. Rick's got it. Can you see that, Jeff?
I see it. Jeff or Dan, can you request control now?
I don't need it now. I think he can go.
No, I mean Campion.
There you go.
No, I can't.
It's okay. We just let Rick drive.
I'm gonna leave and come back.
Should we start anyway?
Yes, please.
Yeah,
So,
okay.
Kev, you mind?
All right.
Well,
Okay. Morning. Hello, everybody. Sorry for the technical difficulties. It's good to have you all here. This is our world that we live in, and we appreciate your patience. This section here today, we're going to do the LC positive displacement flow meter, as well as the other meter brands available with liquid controls. Most of you familiar with the liquid controls positive displacement flow meter. We also have the LC mass that we'll focus on as well. This is a high level discussion, and we'll broaden the discussion or increase the discussion in later times. But you see photos of our positive displacement flow meter. We have the M series meter with the pod pulsar there, as well as the steel case meter. And then you see examples of the Coriolis mass flow, where we have the straight tube as well as the bent tube design. Liquid controls, metering technologies. Many of you may be or may not be familiar, but Fred Wacker was an entrepreneur who was the leading man who started liquid controls. He collaborated with George Richards and created the liquid controls positive displacement measuring principle. That measurement principle has been a success in many different industries, whether it be in military, petroleum, food, and chemical, and became known for its superior performance as well as accuracy. Mr. Wacker, to give you a little brief history, was an avid race car driver throughout the 1950s. He was well known as an industrial designer. And Mr. Wacker became friends with a gentleman by the name of Brooks Stevens. He was an industrial designer who created the liquid controls logo that you see on our boxes, on the sticker on the meter. But Mr. Brooks Stevens was also a designer, well known, and you may also know him as the creator of the Oscar Mayer Wienermobile. Another item regarding liquid controls is why we have the color yellow. It was a color that was associated with safety, but it also was very eye-catching. When liquid controls came into the market, some of the other colors were already taken. You know, Smith had orange, Brooks had a blue or a gray, and the bright yellow attracted people's attention, caught your eye, and it allowed us to focus on safety as well as a new company into the market to get people's attention. Liquid Controls is a positive displacement flow meter. We were established as a manufacturing company in 1954. In 1956, we jumped into the meter industry with both feet in the deep end. We received our first meter order from the United States Air Force, measuring jet fuel at 600 gallons per minute. No small feat for providing the first meter. We are the original inventors of the tri-rotor design, which was invented by George Richards. We are a manufacturer with the help of you with worldwide distribution, and we measure high value liquids for custody transfer applications. Some of those markets include refined fuels, jet fuels, propane gas, anhydrous, as well as many of those clean liquids that you see there on the screen. In 2001, Liquid Controls was purchased by the IDEX Corporation, who is our current owner. Here's a little bit of a history and growth regarding Liquid Controls. There was that first meter that we sold to the United States Air Force in 1958. That starts us on our way. 1954, the actual first meter was created in the back corner of Amco Tools. There you see George Richards on the far right and Fred Wacker kind of in the center. A lot of our growth throughout the years is centered around electronic registration. The meter remains constant, providing the accurate measurement, but our growth can also be tied along with our electronic registration. You see, in 1994, we came out with the ElectroCount 3 register with the other series of registers throughout the progression of Liquid Controls, finishing there in 2019 with the release of the LCR-IQ and the CentralLogic platform. We are a manufacturer, and we provide you with a unique role, as well as other manufacturers, but you expect from us high quality and reliable products. In many cases, we're going to provide you also a predictable delivery and lead time. We're going to provide you with leading customer support, whether it be sales and or technical support. A lot of that is accomplished with factory training. 3 years ago, we did this LC University at a hotel near O'Hare International Airport. We've done it at Liquid Controls factory over the years. And as we've grown, we've needed larger places to do it. And due to the conditions that we're currently surviving through today, we are able to present this to a much broader audience that includes you, and thank you for joining us. We'll also provide advertising. You'll see our advertisements in large trade publications, as well as promoting our products at the very large technical trade shows in the various industries that we serve. You also have a role for us, as whether if you're a full service distributor or an OEM, you're going to stock for whether it be your regional customer requirements. You're going to sell and or promote the product for your customers' metering applications. You probably have technical folks that can provide service within your staff, whether it be on-site, possibly startup on large projects to ensure that the meters are started up correctly and have a long service life. You may have technicians that concentrate on the electronics portion to provide technical support for your customers after you sell a complete metering system. You're going to finance the product within the terms of our agreement. You also may participate in advertising and publications in your local communities or marketplaces, and attend trade shows that are in your area. The biggest thing I see is the communication between our cells. Us as a manufacturer and you as a channel partner, it's a two-way street. And I know I always ask for feedback. Sure, it's great to hear that, hey, we're doing a good job, your meters met the application, but part of that feedback too is where we need to improve and possibly what companies may we could possibly look into purchasing to help complete a solution for all of us to remain strong in the marketplace. They had probably one of the most important questions that I tend to ask as I travel and look forward to doing so again is, hey, what's the competition up to? So between us as a manufacturer and a channel partner in any type of relationship, communication is key. And that two-way communication regarding feedback and support, we greatly rely on and hope you can share that with us. This, again, it's going to be a high level of communication with this presentation. Within the flow principles that we offer, the positive displacement technology is volume measurement. And we offer a tri-rotor design. Other measuring principles that fall in the category of positive displacement technologies could be a birotor, could be a piston, sliding vane, and oval gears. And in the next presentation, we'll look at those a little bit deeper. Also, there is another flow measurement principle that we offer, and that's Coriolis mass flow, utilizing the LC mass meter. And that gives us a weight or mass measurement recording. Here are some of the features regarding the two principles of measurement that we offer. On the left, you see the positive displacement meter. On the right, you see the LC mass. If we're into volume measurement, our PD meter is probably the best way to go. It has a lower cost, low pressure drop. When the meter is operated within its parameters, has a very low maintenance requirement. It can offer high pressure, high temperature applications. It is less sensitive to the type of pump that's used in the application and is very recognized for higher viscosities. You see the application or accuracy and repeatability statements, as well as the sizes that we're able to offer the PD meter in. On the other side, mass flow meter may be considered when weight or mass is required. It is also a meter that can provide a very high accurate and degree of density measurement. It has a higher turn down ratio compared to a PD meter. It does have a little bit higher cost, and depending on the application and the liquid it's going to measure, it may have a higher pressure drop. So you got to be concerned about what type of pump you're using. There's very low maintenance cost and can measure accurately at very high temperatures. The markets that we serve, as you see listed here on this screen, in most cases, we're in the terminal and transportation side. And we refer to that as midstream and downstream applications. And within the midstream and downstream applications, we're looking at the environments of petroleum, liquid propane gas, the aviation, alternative fuels, industrial, and DEF markets. There you see that some examples of us in terminals, in the dispensing markets, whether it be in transportation or in fixed applications, and then it's delivered to end users. The markets that we serve in the petroleum, if we consider it an umbrella, inside that umbrella, we call on, or you call on the major oil companies, and that a lot of them own the refineries and oil production. They have control of the pipeline. We are very strong in the alternative fuel industries, where we see ethanol and biodiesels gaining market share because they're maybe more on the greener side. Within the aviation market space, various opportunities there, whether it be on hydrant carts, refuelers, fuel farms. The asphalt market, summertime here in the North America, that season is picking up, and we see a lot of opportunities there. Lube oil market, whether we're blending or batching lube oils, very fine application for our meters, since we don't hesitate and we can operate very successfully in high viscous applications. The other markets or marketers are independents, and we see some examples of the meters in applications there. We have our steel case meter with control valve, and we see some applications on refined fuel trucks there. Another market we're very strong in, that we serve very well, along with you, our channel partners, is the liquid propane gas application. We're very successful with major marketers. The independents and regional marketers look to our liquid controls meter for long-lasting service. And we have been successful with the farm cooperatives throughout the North America and around the world. Meters are also used in another industry, agriculture. We see chemical dealers, custom applicators, farm cooperatives, fertilizer manufacturers. We have been successful with our meter with liquid feed, as well as in lawn care applications. Picture in the left-hand side is a application for a fertilizer manufacturer that installed that M15 meter on a transport trailer. And he loaded that transport with fertilizer, and that transport went to various communities throughout the surrounding states and delivered a specific amount of gallons to each of their customers. The right-hand side is an anhydrous ammonia application, where the NH3 or the anhydrous ammonia is used as fertilizer. And we used our MA series meter class 12 for that application. Strong market for us is industrial. A lot of times you classify that as everything else, and as we as well. As you can see, underneath the industrial umbrella, there are many subcategories, whether it be food and beverage, paint and coatings, petrochemicals, printing chemicals and such, where we have been successful in metering solvents, chemicals. In the food and beverage industry, a lot of corn oils, high fructose corn syrup, very good application in the baking of foods. Since our meter provides a very high degree of accuracy, it is used in most cases in custody transfer applications. And that means when a person is selling the product from one user to another, it's the custody is transferring from one person to another. We experience that on a weekly basis, maybe a daily basis, at the gasoline stations when we fuel our cars with gasoline or diesel, some cases possibly propane. We see that custody transfer at the grocery stores when people, you go and get a bunch of bananas and you put them on a scale, and we expect that that scale is accurate and the price per pound is calculated based on the weight. So our use in custody transfer is on trucks. Also in stationary applications where we're in bulk plants or loading terminals. Our meters are used in batch processing and blending applications, where we'll see a few further examples coming up. Here's a top level view of the market focus, where our focus that we talked about earlier is more midstream and downstream applications. You can see that that it's after the product has been taken out of the ground and refined, where we start loading that refined fuel onto transports or rail cars that take it to smaller terminals and or bulk plants, where it's further dispensed into transports, fuel trucks, and then onto other applications further on downstream. Now we're going to get into a little bit deeper into what is offered along with the liquid controls flow meter. Dan, are you back with us?
I've requested to
Okay,
take over.
I'll stop control.
Guys, I don't think you need to do that. Just go ahead and have Rick just continue to drive while Dan speaks. If you can see the screen, Dan.
Yes, I can.
Yeah, if Rick, if you don't mind continuing to flip the slides, that would be great.
Okay, we're going to move forward on the liquid controls flow meter products. So go right ahead, Rick.
Hey, I had turned it over to Kevin, so I'm gonna load it back up, I guess. Kevin was actually driving that last one.
All right.
Okay. See it now? Good?
Yeah, thanks, sir.
Okay, ready, Dan?
Yep, all set.
Okay.
Okay. Go. What we're going to be discussing now is the actual positive displacement meter from liquid controls. And the reason why you'd want to choose our particular meter. There's a lot of them out there, and we're going to cover some of them. But when it comes to accuracy, the LC meter design, the LC meter in particular, has no match. We are, as I believe, the best metering principle out there for positive displacement custody transfer. And the reason for it is the meter has repeatability. And the repeatability means that for every time you dispense volume, it's going to have that same volume over and over and over again, so that it ensures that whatever you're dispensing, if it's a liter, if it's a gallon, you are dispensing a liter and a gallon. So we have two methods of displaying that information. One is a mechanical register, and that's what a traditional repeatability has been, is 0.05%. With electronic register, we can actually become even more accurate on repeatability, and that would be 0.03%. And those are both over the entire range of the flow meter. The other element that's in accuracy is linearity. Linearity is from a range of flow rates. If it's a 5-to-1 turn down range with a mechanical register, we're a plus or minus of 0.125% or better. If it's electronic register, again, this is the advantage of going with electronics. We're capable of doing a plus or minus 0.1% over that range. Now, a 5-to-1 range, and I'm going to use the M7 as an example. In the US, we are in US gallons, so it's 100 gallons a minute, or roughly 380 liters. Down to a 5-to-1 range, that would be 20 gallons per minute, or roughly 76 liters per minute. So that's the 5-to-1 range. In the petroleum world, normally they talk about a 10-to-1 range. So as that example, same meter, 100 gallons a minute, 380 liters, down to 10 gallons a minute, or 38 liters per minute. That's the 10-to-1 range, and with the mechanical register, we're better than plus or minus 0.22%. Electronics, we can even get better yet, of course, of plus or minus 0.1%. So there's a great example of why you want to choose our meter and why you want to go with electronic registration. Next slide, please. As far as the flow ranges available from liquid controls, we have a small meter that sometimes considered 1.5 inches. That's the M5. And it starts at the low range of 6 gallons per minute, or 23 liters. We can go all the way up to our MS series line, which is the MS120, and we can get 1,200 gallons per minute on that meter, and with light refined petroleum products, or 4,542 liters a minute. But something that you should always keep in mind, and this next question comes up very, very often, and that is, I want a 1.5 inch or a 2-inch or 3-inch meter. We have multiple flanges that can be added to a different meter, so we can actually have 4 different meter sizes that can be considered a 3-inch or a 4-inch. So don't always size the meter based upon the pipe diameter or the inlet diameter, but size the meter based upon flow rate. We have pressure ratings for our meters. They can start at 150 PSI, which is the most common, and we can go all the way up to 350 PSI, which is an example, would be for LPG. Materials of construction, the most popular size meter we have for construction is the aluminum, the M and MA series. We have stainless steel. We're going to talk about that in a little more in the M series. And then the steel case, it's the MSA and the MSAA series. Well, before I go any further, let me match up those nomenclatures. M is designated for a pressure rating of 150 PSI. MSAA is a designation for a pressure rating of 275 PSI. MA for the aluminum, and the MSA is 300 PSI. The MA would be for 350 PSI. Thank you, Rick. The accessories to meet the approval requirements, and the approval requirements are either established by ourselves as a manufacturer recommending, for instance, strainers to protect the meter, or air elimination systems that are used to meet weights and measures approval. Now, the weights and measures approval in many countries do not specifically say you must have an air eliminator, but they're written such that you must prevent air from going through the meter, which will be counted as liquid. So be careful when you're talking about supplying equipment and meters to applications, that you are being expected by the customer to be the expert in your local registration areas. And so always be considerate of what the application is, whether you need to have an air eliminator or a vapor eliminator. We recommend that all the meters that we supply have a strainer to protect the meter. The tolerances between the moving parts are such that it's 0.02 of an inch nominal clearance in the moving parts. That's roughly the thickness of your human hair. So we want to be able to protect the meter from foreign particles, and it doesn't matter if someone says we flushed this line out so many times, we should be good. there is always something that gets caught in an elbow, in a crevice, or some welding slag that breaks off at a later time. So always put a strainer prior to the meter. Preset control valves. Preset control valves would be based upon the application. If you wanted to dispense a specific amount of product, a preset control valve used in conjunction with an electronic register or a mechanical registration system, a preset, will do that. Will start your flow, and when it gets to that amount that you want delivered, it will shut the system down. So that's more of an application requirement. But when it comes to electronics, you should have electronic register controlling at least an on-off stop valve. That's part of the security system of it. Temperature compensation, we have both mechanical and electronic. Mechanical was used certainly for many, many years, but it has its limitations, but it also has its pluses. For instance, it doesn't need electricity. So in areas where electrical concern is present, maybe mechanical registers, temperature compensator is still being used. But keep in mind, it doesn't have the same response time as the electronic register for temperature compensation. I mentioned earlier about preset, mechanical, and electronic. More and more is going towards the preset doing electronic registration. It is much simpler and easy to do, but you got to be careful with the environment to make certain it meets local approvals for electrical conditions. And then the meter can be customized either as a one single unit, such as what we see in the bottom right-hand picture, with the high capacity strainer, optical air eliminator, meter, register, a preset valve, and then a downstream back pressure valve. That is one simple unit that's typically used on refined petroleum trucks. But it's not to say we can start separating some of those components if the application requires it, not having necessarily mounting everything together. The next slide, please. And getting into a little bit more of the registration portion of it, certainly the pictures on the far right side are the mechanical counter. The lower one has a pulsar that's attached to the counter. In that particular case, that pulse signal is a calibrated pulse signal. And if I can read that, a counter register says it's reading in deciliters. So in that particular example, one revolution of the right-hand wheel is 10 deciliters, which is an increment of measure. But the pulsar could have a pulse generator that delivers one pulse per revolution, or one pulse per 10 deciliters, or 10 pulses per revolution, which is giving me one pulse for every deciliter. Or you can put a 1000 ppr pulsar on that counter register. So for every revolution, you're going to get 1000 pulses, or 100 pulses per deciliter. So if there's still questions about pulse resolution, just keep in mind where you're going to mount that pulsar and if it's a calibrated pulse signal. Now, right below it in the lower right-hand corner is the pulse output device, the POD, we commonly call it. That's attached to the front of the meter and driven directly by the blocking rotor. That is an uncalibrated pulse signal. So that's the difference between the mechanical register with pulsar attached to it and the POD that's attached to the front of the meter. POD is not calibrated. You send that to an electronic register that's going to take that pulse signal and calibrate it to give you an increment to measure. And those electronic registers are pictured to the left. The first one's an LCR 600. The middle one is the LCR 2. And the one on the far left is the LCR IQ. All of them can have pulse input signals. You use the register to make it a calibrated signal. Therefore, your display is going to have the correct volume that you're wanting to dispense. Also with electronics, you can do the temperature compensation preset, and you can send a signal to a printer to print your delivery tickets. Most custody transfer applications require that you you print a delivery ticket with the information of the delivery, the product, if it's temperature compensated, if it's compensated to either degrees Fahrenheit or degrees centigrade. And that is the receipt that the customer would receive for making that delivery. The next one, please. Part of the reason why you're seeing electronic temperature compensation becoming more popular is certainly price. And the price on this one, as you can see as a comparable, the printer, counter, mechanical TVC, preset gear plate, and adjuster, their list price totals up to be $7,055. To do the same thing electronically with a printer, counter, ETVC kit, the preset being built in, no gear plates required, and the mounting kit for a temperature probe is $4,126. The dependability of the electronic temperature compensation, the high-speed response to the temperature changes of the product, it outweighs anything that the mechanical temperature compensation can do, and it's less expensive. But I did mention before that there may be an application where electrical restrictions are prohibitive for you to do electronic temperature compensation or even electronic registration. So there's still areas that we do sell mechanical registers and compensators for. But more and more the industry is going to electronics. Next, please. Here's an example of an M30 meter that is mounted in a bulk plant situation, and it's using a pulse output device, which is in the center. That's sending a signal to an electronic controller that's remote mounted. Unfortunately, I don't have a picture of that, but to the right of the meter, there's a strainer inlet. Above it is the air eliminator. So this is telling me that this is an application where it's going to require high accuracy. It's offloading, and it needs to have the means to make certain that there is no air going through the meter, because we will count air as liquid. Therefore, the accuracy will be extremely bad. To the left-hand side of the meter is a flow control valve. That's a two-stage, again, being controlled by a separate electronic register remote mounted. Thank you. So we have another application would be truck metering. So these are the mobile applications. Certainly the one in the middle is probably used the most for liquid controls meters as refined fuels. But we're also very prevalent in the aviation market and certainly strong in the LPG market for home deliveries. Next, please. In the petroleum industry, that probably is by far the largest market that we're in, but it's sometimes not really noticeable because it's always behind the scenes. So we do fuel oil delivery, rail, truck loading, and marine barge. Again, these are requirements that would have custody transfer, so high accuracy. And we can then work with other devices to do terminal automation. And certainly the electronic registers from LC, the Electrocount, and the Centrilogic IQ. Okay. Expanding more upon the LPG industry, we've seen this as a growth industry over the last 10, 15 years in particular, because it's becoming very popular. It's not as fearful of using by the general public as it once was. They were more afraid of it. Now it's more convenience because it's very portable, and everyone is talking about cylinder fillings and using cylinders for recreational use. It's probably the best type of portable fuel for recreational use, but it's expanding even more into LPG dispensing in the US, but it has been doing that for a number of years internationally. So we see that LPG dispensing, we have a small MA4 meter that's used with dispenser companies that do it as an OEM product. Certainly the LPG industry when it's a bulk plant for loading trucks to do inventory control. And the most popular one is the use on LPG bobtails, where they're delivering directly to an end user or a customer on that. This is also one where we can combine it with the Z-series pumps from our sister company, Corkin, to make a package. So therefore, we're completing the industry of movement, measurement, and management solutions. Next one, please. Aviation industry. This is one that I use this a lot to share with my family when we're traveling, because if you can go to many airports around the world, certainly in North America, and if there's a truck that's there to fuel the aircraft, or if there's a hydrant cart to fuel that aircraft, you will see a liquid controls meter, and it's certainly a very proud moment, especially when you consider that the very first meter that LC manufactured was for jet fuel, even though it was for the military, but it was for jet fuel, and that's where we got our start into it. Now with that industry being very cautious and conscious about the fuel and where the fuel is located, electronic registration has been a very strong point for that industry to move forward, because they all need to know where the fuel is going to, what airlines is getting it, and how much they have in certain areas. So this is one that's been a really strong market for us. Unfortunately, the COVID has sort of suppressed this industry, but all indications are that it's going to come back, and it's going to come back extremely strong. So we're looking forward to that. Next one, please. Alternative fuels. This is one that's been around in some parts of the world for many years, but it's getting more and more traction, certainly here in the US, because just recently they now are able to start blending for fuels of gasoline up to 15% ethanol, which is something very new. Otherwise, it was typically up to 10%, but now they've gone to from E10 up to E15. The other is on diesel fuel. They're using biofuel to supplement part of the product for gas for diesel, and this has certainly gained traction in the farm areas, the Midwest of the U.S., because that's where a lot of these products are being manufactured or grown, harvested. So blending systems are very strong now, where they can take 90% gasoline and 10% ethanol and create the E10 blend, excuse me. So we do it also in storage. So they have to have that fuel someplace, and you need to know how much you have in it. So when you make deliveries or receive deliveries, you'll use the meter to flow it. Again, if they're looking for high accuracy, that's where we thrive. And we do the opposite when we do loading facilities. As transports come in, trucks come in, the bulk trucks, they're going to need to know how much fuel they're taking out of each of those tanks. Because the worst thing that can happen is if they don't know what their inventory in these bulk facilities, so they know how much they have and when they need to reorder. Because no one wants to have too much fuel, no one wants to have too little fuel. Next one, please. In 2010, the United States started pushing for diesel fuel being augmented with DEF, diesel exhaust fluid, to help clean the exhaust emissions. Therefore, we had to come up with a meter to go with that industry, because it can be very corrosive. It also needed to make certain that it was very pure, because you're limited on the amount of parts per million of contaminant in diesel exhaust fluid. So we have our class 18 meter that is a stainless steel constructed meter. We can't use any aluminum components with it. So we're either using stainless steel or some type of a polymer in order to be in contact with the liquid. And the pictures of the examples is the M7 class 18. On the left, it has an inlet strainer, and on the right, we have a control valve in order to stop the flow. In that particular example, there's no air eliminator because that's coming from a dedicated tank. What we've recommended in the dedicated tank system is using an optical sensor on the discharge side of the tank. A position, is critical because it's based upon flow rate. But what it does is it will shut the valve down once the tank starts to come to empty position. Therefore, if you don't put any air into the system, you won't have to try to bleed it out. The other two photos do show an air elimination system on it because in those examples, they probably will be emptying those tanks out because those are on bulk truck deliveries. So if it's not a dedicated tank, or if they want to make certain that they actually take all the product off, they can do that. But that's why you will have a mechanical air elimination system there. Next slide, please. We started out selling LPG motor fuel dispensers internationally because of the demand in the product line for the OEMs and the use of the LPG as motor fuels. It's becoming more and more popular in the US. And we work with some of our valued distributors that actually take our MA4 meter. That's the picture of the one on the left. That's actually a dual-sided dispenser system. One meter would send the electronics to facing curbside, if you will, dispenser, and the other MA4 would send the pulse signal to the other side of the electronic register, so you could fuel both sides of the island at the same time with LPG. And then the one on the right is a boat dock fuel dispenser. While it's not LPG, that would be used for either gasoline or most likely diesel fuel, because it's a higher volume flow rate than what you would see for small outboard engines. Okay, one more. This is a bulk fuel truck transporting a loading system. You can see the loading arm and the API couplers, electronic register, high capacity strainer, mechanical air eliminators. Sometimes people are wondering, why do you want to have an air elimination system when I've got this large storage tank? And you told me earlier, Dan, if it's a dedicated tank, we may not have to have air elimination. You would have air elimination because as the product heats up or cools down based upon the time of day, how much sunlight, the product expands and contracts. In the evening, when it contracts, there can be some small air voids that are induced into the piping system, and therefore we don't want that air to go through the meter, so we'll have an air elimination system on it. Other areas will require, by weights and measures, to have an air eliminator in there. So many times I've seen the air eliminator there, but both vent ports are plugged. That's not a good application. Make the system designed so that the air eliminator is functional, because you will need to use it. And the picture to the right is a rail car fueling loading system. And that was a picture that the M30 meter that you saw earlier. So those are just some of the applications that we see for liquid controls meters. And I'm going to now ask to have the next slide and turn it over to Mr. Rick Hembry.
Okay, can you hear me?
Yes, I can.
Can you hear me? Okay, all right. I didn't know if I was muted or not. Yeah, we've been talking about the positive displacement meters, and as Dan and Kevin mentioned, Liquid Control has been manufacturing positive displacement meters since the 1950s, 1956. But we also have another meter technology that we'd like to talk to you about. And, we did have the sponsored turbine meter line at one time, which is no longer available. So if there's some applications out there where you cannot use a positive displacement meter, it may be an option to use an LC mass meter. And the LC mass, it's a Coriolis meter technology. And this metering technology provides indication of measurement for mass, density. It can do volume. It can do temperature. So if you need to know a weight of a product, this technology provides that. If you need to know a density of a product, just for instance, like LPG, if you want to convert that from mass to a volume, you need to know the density of LPG. And a couple of model meters that we have the one on the bottom down here is a dual bent tube design, and the one on top is a dual tube straight tube design, which is lower pressure drop, smaller footprint than the one on the bottom. The one on the bottom is the dual bent tube is for higher flows, better accuracies, higher temperatures, but I'll go into that here in just a few minutes. But wanted to talk to you about the principal technology of the Coriolis mass flow meter. We have a housing, and inside this housing we have what we call measuring tubes, 2 measuring tubes, and we have a driver that actually drives these tubes. And if you look at the picture on the bottom, during no flow, we have a sensor on the inlet and a sensor on the outlet. And this driver drives these tubes, and it's a known frequency. So we know that frequency that those tubes will be being driven at. And once we introduce flow into the measuring tubes, you look at the picture on the right bottom, you see the tubes start to wobble. And this wobbling effect is called the Coriolis effect. So we take a reading from the inlet sensor and the outlet sensor, which is the phase shift between those 2 points. And that phase shift that we measure is directly proportional to the mass flow rate. And again, we have a couple of models. The first one is the LC Mass 100. This is a dual straight tube mass flow meter. It's mainly used for general purpose applications. It also can do density measurement. Sizes 1/2 inch up to 3 inch, and the range 240 pounds per minute up to 6,235 pounds a minute. It has 0.15% linearity and very good repeatability at 0.05%. And this unit right here is the dual straight tube, which is good for, you can use industrial applications, smaller footprint. If you have an installation that requires limited space, this dual straight tube may be an option as well. The LC Mass 600, this is the dual bent tube mass flow meter, and it for applications that demanding the highest flow and density accuracy, high pressure, high temperature, and it also can be used in cryogenic use. The sizes for this meter is 1/2 inch up to 10 inch, and it has a larger flow range, 22 to 36,743 pounds per minute. And the linearity 0.05 at a 10-to-1 turn down, and repeatability 0.05% repeatability. LC Mass 100 again, accuracy 0.15 plus minus 1.5%. Economic design, this is the dual straight tube. Again, smaller installation envelope. So if you have an area where it's a tight space, then this may be an option. It also is a lower price than the 600. Low pressure drop. This design with a dual straight tube has minimal pressure drop, even at higher flow rates, and has a rigid housing. And this rigid housing is a secondary containment, and it helps in isolating from environmental vibration. And one thing about the Coriolis mass flow meter, if you have any external vibrations, for instance, if you have a meter on a truck traveling down the road and you have a lot of vibrations, it could interfere with the tube vibration signal and cause for inaccurate readings. So this unit here is with the secondary containment. It helps in isolating some of those vibrations. The 600 for highest flow and higher, and for density accuracy, 0.05% to 10-to-1 flow rate turn down. The high turn down ratio, 0.1% to 21 flow rate turn down, and the density measurement plus or minus 0.008 pounds per gallon. So very, very accurate if you need to do density measurement. Also wide range from minus 328 degrees up to 752 degrees Fahrenheit. So a very wide flow range if you have an application where you may need to do some cryogenics or if you're doing some like heated caustics or that type of product, this meter may be an option. In order to take the signal from the sensor to get a reading, we need a signal converter. And what we have is the LCI40 converter. And this converter is a 4-button interface. It's easy to use, easy to maneuver around the screen. It has multiple output variables. It could configure mass and volume, flow rate, temperature, also density, flow total, and status outputs. So it can give you a status output determining on the condition of the meter. If you may have extreme temperatures, it can give you a status, temperature readings, and that. If multiple output signals, we can give pulse output that can be configurable, a 4 to 20 milliamp output, analog current, frequency outputs, signal diagnostics. So if you're doing some monitoring or troubleshooting, it's good for troubleshooting. In-train gas management, in-train gas alerts and measurement. If there's any in-train gas within the liquid, then it's going to give an alert. Last thing we want to do is measure gas or anything in a liquid. So if it's a gas in the liquid, then it's going to give an alert. Some of the applications, again, is used for mass measurement and also density measurement. We can convert that also to a volumetric measurement if need be. Unloading and loading of transports, trucks, and barges. If you have a blending application in, say, aviation, refined fuels, diesel exhaust fluid, LPG, it's ideal for that those applications. This installation here, the first picture you see is the LC600, which is the dual bent tube, and you see it's a larger envelope. The one in the back is the LC100, which is a smaller footprint. You can see the size differences between those. This next picture is actually the same installation. You can see in the front is the dual bent tube. You can see the accessories, the air eliminator, the strainer, got the valves to go with it. The one in the back is, again, the dual straight tube. Again, a smaller footprint. And this picture here is the dual straight tube. It's got the accessories with the strainer, the air eliminator, also the valve, differential valve. Shows, I think that's got, it's got a pilot on it. So what meter should I use? I know we talked about earlier the positive displacement meter and talked about the LC mass meter. The LCPD meter is best for volume measurement. If you need to do a volume measurement, it's a lower cost. It has a low pressure drop, low maintenance cost, high pressure, high temperature, less sensitive to pump type. So if you're using a pulsating type pump like a diaphragm pump, really no interference using this pump. Good for higher viscosities. It has great accuracy, great repeatability. The size range is from 1.5 to 8. The LC mass is best suited if you need to do a mass measurement, if you want to read out in pounds. In weight, best for density measurement. High turn down, 20 to 1. However, it is the highest cost, it's more expensive. Highest pressure drop, low maintenance cost, and also good at high temperatures. And the accuracy, excellent accuracy and repeatability. The size ranges is 1/2 inch to 6 inch, which, one thing that, when we're selecting a meter, don't necessarily look at the size of the meter. We need to know the flow rates, because some of these smaller or larger meters can handle a good bit of flow. And applications for jet fuel, got a couple of examples here. Recommendations at 1,000 GPM, 100 PSI at 80 degrees F. As the viscosity is acceptable, we can use an LCPD meter, or we could use a mass meter. Just depends on the viscosity. An LCPD meter class 2 would work and would be relatively low in price with good accuracy. The LC600 mass would work as well and would offer a slighter better accuracy, but will be very high price. This meter will be a lot more expensive and not currently accepted in the aviation refueling due to the high pressure drop, and would require an 8-inch for flow rate required. With this dual bent tube design, it does have a higher pressure drop. So that's one thing we need to do when we size the mass flow meters. We need to look at the pressure drop just to see if that application can handle the pressure drop. Okay, this is jet fuel with 30 SSU at 1,000 GPM, 100 PSI, 80 degrees F. And I think this is the slide that we had just talked about. Okay, I've lost control. Do you have control, Kevin?
I requested it, Rick, if you could.
Okay, yeah, I can't. Oh yeah, I can't move the screen, so that's the reason. Okay, you got it now. Sorry about that.
Our next application, we're going to focus on lube oils. The viscosity of the lube oil is 1,500 SSU. The application requires 100 gallons per minute, pressure rating, and the temperature, as you see there. We could apply a liquid controls positive displacement flow meter. Because of that viscosity, we would select our class 14. Comparatively, it's relatively low price with very good accuracy. We could also apply a LC mass meter. It would be either the LC 100 or the 600. The 600 would offer a little bit better accuracy, but at a higher cost. With the viscosity, it might provide us a higher pressure drop, which may require a larger pump. The LC mass, though, since it's a straight through tube, would be a consideration because of a less pressure drop. We have a sizing program that we could work along with you for these applications and provide a solution for when we look at the LC mass, which one might better fit. With every application that we look at, we're going to always look at the application details to determine the best accuracy available and the price comparatively, and what's best going to meet the customer's requirements. And we'll work together on that. Rick, you might have to help Dan and go to the next slide.
Okay, I don't have control of it. Let me. Yeah, I don't have control. Do you have control of it?
I released it. I'll request it again. Dan, looks like he has something there.
I
Yeah.
requested control, but it wouldn't allow me to move to the next slide, so I don't know what's going on there. But if you could go ahead and, this application is LPG loading or transports, 200 gallons a minute. The meter we would recommend would be our positive displacement meter, class 10. It's probably the most economical and the best accurate meter for that application at the flow rate. But we could also offer the LC Mass 100 and LC Mass 600. They are stationary applications, so they would be suitable. And it would be certainly a higher price. So it comes down to what does the customer want and what is he willing to pay for it. Another one. We do recommend on the mass flow meter that it also has a vapor elimination system, strainer to protect it, because those particles could go through the meter and be counted as liquid, and that's gives us erroneous errors. So there's also should be a control valve in the system. And whether or not that application requires weights and measures approval. And this should be determined by the local, work with the local regional manager, but also work with the local weights and measures. Because even though we've been familiar with PD meters and with mass flow meters, some weights and measures may not be that familiar with those devices, and we are. So help them out, work with them, and therefore we can offer the best service and products for that application.
Yeah, I think that was the end of the slides there, Dan.
That concludes the first presentation. Again, we appreciate your patience with our technical difficulties. And we're just going to take a 2-3 minute break since we are running a little bit over to get the next presentation up and give you a chance to break. So at about 10:20, 10:21 local time, we'll get started again. Rick, since you're running the show, do you have the next presentation?
Yeah,
Available?
yeah, I just put it up there. Can you see it?
No,
Oh, you can't?
no, we're still on the 101.
Okay, let me. Do you see it now?
Yeah, perfect.
Yep, see it.
Okay. Okay,
Thanks,
good.
Rick. While we have a pause here, if anybody has a question they want to address to the team, feel free to raise your hand. There's a little hand raise emoji, or you can unmute yourself and ask a question if there's some silence.
Sorry, this is Subodh from National Energy in Canada here.
Hi,
How are you?
good. How are you?
Good. The DEF meter was at class 18. Is it class 18 or class 8? The DEF meter would be.
Class 18.
18 is in,
Yep.
Okay. And what price list would it be in?
There's a special price book, I think, for the DEF meter,
Oh,
the
okay.
class 18 meter.
All right. Okay. Thank you.
It should be on the distributor website if you
Yeah,
can access that.
Sure. Yeah. Thank you.
Okay.
Hey, Rick, Rob Rose with National Energy Equipment here. I do know that talking with Royal Wolberg in the past and a couple other individuals within your group, I know there's been some challenges with the Class 18 for Canada. Are you guys producing the Class 18 DEF meter for Canada still? Because I know there was a bit of a holding pattern on that. So if that's changed, that hasn't been conveyed to our group.
We're still in that position, Rob. We haven't made any changes in regards to the acceptance in Canada.
Okay.
Either Royal and or Lee will inform you when we are able to meet those requirements.
Do you know if there's anything on the agenda to have that looked at in the near future?
Currently, right now, I don't believe so. In the conditions that we're at right now, that may expand in the next several months once we're relocated. But currently, we'll have to double check and address that question offline with you at maybe later today.
Sure, yeah, no, that's fine, right? I know we can use it at least for stationary. We can always look at mass flow as far as truck mounted. Well,
correct. Yes. Yeah. For
kind of
the mass flow will meet your requirements for loading, but for vehicle mounted, we don't have an approval in Canada for the mass flow meter on trucks.
Sure. No, yes.
I was going to say, I see that both Lee and Royal are on this presentation, so they're listening. So
Sure.
we can get back to you on that after this.
Yeah, no, that's fine.
Cool. Thanks, Rob.
Appreciate it.
Hey, Rick, are you seeing my request for control?
Yeah,
Can you allow me, please?
there you go.
All right,
You
perfect.
should have it.
All right. We unfortunately, with the technical difficulties, we got off to a late start, so we're going to jump right into the next presentation where we're going to concentrate specifically on the liquid controls PD meter. You see here the presentation, we have the M series, or in this case, specifically MA series meter. We're showing the aluminum meter, strainer, optical vapor eliminator, the LCR-IQ register, preset differential valve, and on the right-hand side, we see the steel case spherical meter. It has a ANSI flange connections and pod pulsar output. Some of these screens are repetitive, but worth repeating. A lot of the markets that we serve with our meters, major oil companies, oil production, pipeline, alternative fuels. I'll highlight where we're very successful with the Illinois, ethanol, biodiesel, aviation as large umbrella where we have the carts, refuelers, the fuel farms, asphalt, lubrication oil marketers, just to name a few. Also, again, within the liquid propane gas market, we're dealing with the major marketers. All of us have regional marketers within our area responsibilities that we can speak to. The independent marketers, as well as the farm cooperatives, offer us a large opportunity, whether if we're loading transports, measuring out of our bulk plants, dispensing from smaller tanks, and in the truck to customer market. Agriculture market, chemical dealers, custom applicators, the farm cooperatives, again, the anhydrous ammonia market in some parts of the world is used used widely as a fertilizer. We can call on the manufacturers as well as the liquid feed and lawn care companies. Food, beverage, paints and coatings, a lot of industries that we talked a lot before. due to time, I'm going to kind of gloss over this a little bit. Again, custody transfer, where a high degree of accuracy is required, where we excel. And that is in mobile applications where meters are mounted on trucks, and the stationary applications, the bulk plant, the loading terminal, the fuel farms. Very high rate of accuracy required, and we can provide that for you. Batch processing is another, if we are filling drums, totes, large containers, we can provide that accuracy over the various flow ranges and in the blending applications, and we saw that earlier. The advantages of utilizing our meter are, as Dan talked about earlier, superior linearity and repeatability, accuracy. All of the accuracy statements that you see, whether it's on this slide, on any piece of literature that you have, pick up at trade show or have in your office, or you find on our website, those statements are based on a product of 1 centipoise or 30 SSU. If the product gets thicker, our accuracy only improves. How do we sustain this accuracy, or what does it mean? If you look at the picture, you see our tri-rotor design. Each of those rotors, we have a balanced displacement rotor at the top. We have 2 imbalanced displacement rotors towards the bottom. I'm sorry. The one at the top, the balanced, is the blocking rotor, and we have 2 imbalanced displacement rotors. They're supported on either side by a bearing plate. And what keeps those rotors from in that synchronization are timing gears that you see, that you can't see, but on the back side of that picture. And they rotate inside that meter housing. Well, Dan mentioned that the tolerances between all of these parts is about 2 thousandths. When we introduced liquid into the meter and the rotors start turning, those parts don't touch one another. If they don't touch, there's no wear. So the tolerances remain, they don't increase. And if they don't increase, there's no slippage. So if the parts don't wear and there's no slippage, what that means is we can sustain the accuracy over longer periods of time. And in future slides, we'll see other metering principles that may not be able to make that claim. With the combination of minimal seal or slippage area, and as those rotors turn in their cylindrical bores in that meter housing, there's very, very low pressure drop and across that seal. This allows us to have that superior flow over that wide range of flow. You know, we talked about accuracy from a 5-to-1 range or a 10-to-1 range. This minimal seal or slippage area allows us to achieve that accuracy over that range. Here we show our M series and MS series meters, and we have removed the front cover from that top left-hand side picture. But when you get a meter in the box from us, from the factory, you have a front and rear cover on either side of that measuring element. In our steel case design, that measuring element is encased inside 2 half spheres. When we introduce liquid into the meter for the first time, it also, that liquid goes on either side of the bearing plate. And what that does is balance the pressure on either side of the measuring chamber. So we have the same pressure internally and externally. Therefore, that meter element cannot be stretched or distorted, which allows us no changes in that seal area that would affect accuracy. A lot of the parts in that measuring element are made of similar materials, which have the similar coefficients of expansion. We then allows us to measure products accurately over a wide temperature range. There is one caution though, is that if we see an increase in temperature, we want to introduce that into the meter very, very slowly. It does not like a 20 to 30 or 40 degree rapid or instantaneous temperature change. So as the temperature, in many cases, the meter's mounted outside if we're loading transports or rail cars. In some cases, the supply may be housed indoors, or since it's a large volume, it maintains a higher temperature. We definitely want to introduce the higher temperature liquid at a slower rate, since those internal parts have a very low clearance. The way that those rotors turn inside the housing allows for a very smooth flow characteristic. That liquid has no compression or vacuum exerted on it. So the standard design is capable of metering product not only at that 30 SSU, but as high as over 1,000,000 SSU. And when we have product that is over 150 SSU and greater, there is no need for calibration change. And the next slide will kind of share or expound on that a little bit. We did this independently, and it may not be recommended in the field, but this was a test to validate that previous slide statement. And it shows us how we are able to meet international weights and measures accuracy requirements. So what we did is we took 1 meter and we calibrated at an independent lab on kerosene. And that's that middle accuracy that you see inside that orange square. It shows the typical liquid controls accuracy curve. It was calibrated at 100%, or in this case, the M7 meter was calibrated at 0 deviation at max flow, 100 gallons a minute. Without calibration change, we then tested gasoline, which is a lighter liquid. But as you see from the accuracy curve, it held back at lower flow and gave away at the higher flow. But we are still well within the international standards of accuracy. The third test we did was a product of higher viscosity, a fuel oil, measured about approximately 43 SSU. And you can see that the meter tended to hold back, but also well within the limitations of international weights and measures requirements. And it just kind of validates what we showed in the previous slide, that the meter is capable of accuracy at varying grades of viscosity. Rick, you may need to advance for Dan.
Let's see if I can get it this time.
Okay.
Yep.
I think SU is.
That I hope it was.
I think it was. I didn't touch it. So.
Okay, thank you, Kevin, and thank you, Rick. The next session that we want to go through here is competitive metering principles. Now, we've associated some common names with these different principles, but it's really the metering principle we want to talk about. And sometimes the best way is to know how these different products work, how they measure the liquid like we do, or try to do like we do. And then you can have a better understanding why we're better. So we're going to be talking about the oscillating piston design that's most commonly known for Neptune, a sliding vane type design, which is from Tokheim. You may not have know the name Tokheim, but it was in the industry for a very long time. But it's a sliding vane, similar to what you see in some pumps. The Avery Hardall, which is also a variation of a sliding vane meter with that. That's it. Oops, it was me. Sorry. Reciprocating piston, where that application's at. Nutating disc, oval gear. There's a birotor meter from Brody, and then the sliding vane meter that's from FMC Smith. Now the Neptune, or Red Seal as it's known today, is an oscillating piston. The shaded area in the center, that's a fixed location in the metering chamber that has a wear plate that divides the inlet and outlet. And then it has a hub that's on the middle of this piston that's oscillating back and forth. The wear points are certainly where it touches this wear plate. And also this hub, which is a bearing that's going to be rotating around this open circle area. As those begin to wear, their accuracy becomes less and less, because what they're trying to measure is this chamber that's here. And I'll go to the next slide and you should see a better sequence representation of it. Here again is the meter principle when you're looking down into the metering chamber. So this is stage one, where the product comes into an inlet. It forces the piston around, and it goes to the outlet, which you'll see in the next couple of slides. Those dark areas now are where there's going to be wear. Through the years, they've tried to improve the wear, but also these are all brass components, and the meter was at one time all cast iron body. They've now tried to do other materials to make it much lighter weight. But by sacrificing the original design, such as the piston being a hard-coated anodized aluminum, they are also causing it to wear more. So this is one where the accuracy changes over time. Therefore, having it calibrated at least on an annual basis is a necessity. Without that, they're going to be giving away product. And a seller certainly never wants to give away any product. Another metering principle is a sliding vane that comes from FMC Smith. Again, this is looking down at the top from the top of the meter into the metering chamber. This is their typical G series meter to the right, but the principle is the same. They have an inlet flow and an outlet flow, and the flow is actually pushing the drum or the rotor inside that houses the vanes, and the vanes are coupled to a set of bearings, excuse me, and those blades are being forced out by using this cam. So as the rotor is turned, the cam forces out against those bearings, and then the blades go against the inner meter chamber. That causes it to wear also. That's why they have multiple products that are used for blades. And in some cases, they're using bronze blades. So that's one that will wear, and over time, the accuracy of the meter begins to falter. This is another of the the FMC Smith meters, it's the Prime 4. Instead of having the rotor in a vertical position, they have their rotor in a horizontal position. It does help them, their stability, because of going back to the other slide, there's a bearing at this point for this for the shaft of for the cam. That bearing is located at the bottom here. And that's also an area where it's a stagnant product liquid. If there's anything in the liquid itself, it settles out. It'll settle out in that area, causing that bearing to fail. So they came up with this design by going horizontal with it. But the problem with this design is they made this casing much lighter, so therefore it's susceptible to pressure changes. That's why you'll see in Smith literature, they will tell you what the accuracy change is if there's a product change in pressure. We don't need to do that on ours because, as Kevin explained earlier, we allow the pressure to be in both sides of the measuring chamber to try to keep the differential pressure down to acceptable levels. Here we go. Oh, I'm sorry, a little too quick on the fingers. We'll call this one the Avery Hardall meter. It's a sliding vane meter, but it has an inlet and an outlet that are 180 degrees from one another. By adding a manifold, you can create an inline flow like we see here, but the product will come in, go around, and then exit. Excuse me. Avery Hardall was originally designed in the UK, so it's a very popular international meter because it was many, many years. It's also one that's probably the most copied. There's a number of companies in Europe that have copied it. Satam, which is a French company. Alphonse Haar is a company located in Germany. And also Isoil from Italy. And there's probably others because it's a very popular international meter design. And therefore, it has been copied by a number of companies out there with it. This is a Brooks Brody. This is their birotor meter. As you can see that this one actually comes at a right angle to the rotors that are being supported on either end with a bearing surface. So the product comes in, beats the rotors, then it is divided to either go downward to the lower rotor or upward to the upper one. And then the product actually goes around the rotors, not through the center, around the rotors and out. It's a good meter when it's a light product, but if there's any particles or heavier viscosity, then it starts to have its falter times. They also produce another meter. It's also a rotary, but it's on the horizontal axis in line with the product flow. So in this case, the product comes in, it goes into these vanes, turns the vanes and comes out to the other side. Again, it's used in light products, light viscous products, but when it starts to have anything viscosity, then it also has problems with pressure drop and causing these rotors to fluctuate. Another metering principle, this is probably the second most copied design or principle in the world. It's called an oval gear. And there's a number of companies. Tuthill is one here in the US that uses it. But throughout the world, there's an oval Japan. There's also oval gear meter in Eastern Europe. So it's used on lower flow rates, but it also should be used in light products. Because what we're not really showing here is on the oval gear here, and the second one, there are teeth cut into the outer edges of that gear, and they mesh right there in the middle. And what the product does is as it comes in from the left, it's separated to either go upwards or downwards, and it takes the path around the outside of those rotors. So if it's a light product, normal gear teeth that are cut into it work well. But if it's any viscous liquid, now they have to know the viscosity of the product and it can't change very well, because then they actually remove some of those cuttings of the gear teeth on the oval gear to make the product come out to the other side. Otherwise, their pressure drop is extremely high also. And then another competitive meter is the Coriolis mass flow meter. Coriolis mass flow meter, it certainly has its place in the market, but there is times where it is very expensive to purchase. It can be very expensive to maintain, and you still need to have the ability to strain the product before it goes into it, and also the air elimination system. This particular one is depicting a different an LPG application, so there's also a differential pressure valve. So this is an inline, therefore, as the mass meters go, it's a lower pressure drop than others, but it still has a high pressure drop system to it. And as Rick explained in the earlier one, it actually is using 2 tubes inside this piping. So even though it may be a 2-inch or 3-inch connection, the tubes internally are considerably smaller because they want to be able to use the Coriolis effect of those tubes vibrating against one another, causing that Coriolis mass meter effect to be used. Now I'm going to relinquish control to this to Mr. Hembry, and he will take you forward. Thank you.
Okay. Make sure I don't think I have control. Did you give it back, Dan? Okay, there we go.
I think there's just a little
Okay,
bit of a
can you hear me?
delay.
Oh, okay. I guess you guys can hear me, I guess.
I can hear you, Rick.
Yes, we can hear
Okay,
you.
We
okay.
hear you, Rick.
Yeah, didn't know if this screen here, I can't see my mute button. I apologize. So, but yeah, this section here, we're going to talk about selecting the size and class of an LC meter. And, you know, this section here is important when, you know, you're sizing a meter and critical in making sure that we have the correct meter for the right application. And this chart here, the model description chart, just goes into how we build an actual model number or configuration number. Start out by just looking at the top up here, the M, that would be for your pressure rating, M. Then you come to your case, which would be non-steel if you left it blank. If you went with the S, it would be steel. Then the next chart is your pressure rating, and that's like the blank 150 psi. You see that mainly in some of the class 1 meters and some other meters as well, that class 8s that are not for higher pressure. The AA and the A, that designates, when you see that designates a higher pressure application. And then you get into the B and C, which is higher pressure applications. The size, the next column, the smallest meter is size 4, which is good for 30 GPM, the 5, 60 GPM, the 7 up to 100 GPM. And as you can see, we go down to 120, which is good up to 1000 GPM. And this next column is critical when you're adding your accessories. And if you look at the charts on the bottom left-hand corner, you got the mechanical meter packages, and on the right, you got the electronic accessory packages. So you can actually just look and see what accessories you need, like if you need a counter, strainer, air eliminator, printer, preset valve, or if you need just a meter with a pod pulser. And for instance, the combination A would give you a meter and a counter. B, you go to C, you'll be adding a strainer and an air eliminator. And K is a popular model. The K, you have the strainer air eliminator, the preset valve, and you can see on the electronic side of it, the C would give you the strainer and air eliminator, and A would be the meter, but the electronic register. So just very critical when you're selecting what accessories you need to make sure you fill that out correctly. And if you need to add any additional accessories, like a temperature compensator, you just add the T. For an air check valve would be an X. And, if you need a differential valve for class 10, class 12 meters, you can add that as well. And Liquid Controls uses class for their meter applications. Class 1 is for refined fuels, class 2 for aviation, class 3 is for your sugars, class 4 meters are for treated waters, class 8 is for your acetic products and also some caustics, class 10 is LPG, class 12 is anhydrous ammonia, class 14 for crude oil, and 15 is no longer available. Sorry about that, but should have taken that one out. But class 16 is for your general solvents. And there's 5 basic considerations when we select a meter. And this is very critical when trying to get information on selecting a meter. There's other information that we'd like to have. As much information as you can get would be beneficial, but this is a good starting point to ask just so we can actually select the correct meter. The product class of the meter, the liquid to be measured, it helps in selecting the correct metallurgy of the meter. Also, can ask a question of, is this the only product that you're going to be measuring in this meter, or down the road are you going to be adding a product to it? So it's always good to know that. The flow rate, we can size the meter. For instance, 50 GPM meter and 800 GPM meter is going to be 2 different size meters. So we need to know the flow rate. The pressure rating, M for 150 PSI. And when you see the A beside it, that indicates it's a higher pressure application. The MA is 350 PSI. And also selecting the seals. We need to know the temperature. That helps in selecting the seals. Also, we just want to make sure if it's a higher temperature, we may have to go with an extension somehow on the meter to get that register away from the heat. And viscosity. Viscosity is very important, selecting the size of the meter, because if we increase the viscosity, we may have to look at, if the viscosity gets high enough, we may have to look at a larger size meter. Determining metallurgy, the liquid to be measured indicates the metallurgy of the meter. For instance, on your solvents, your liquid sugar, your water, your fuels, LPG, we use aluminum housing meter. On your caustics, acids, in the class 18 meter we talked about earlier, diesel exhaust fluid is a 316 stainless steel. And also the flow rate. The maximum published flow rates that we have are based on well lubricating products having the viscosity of water. So if there's a higher viscosity product, we would need to know that. So it may change some of the flow rates that we're looking at. And there's also some meter classes. The 4 and the 8 are D-rated at 80%. So for instance, like a M7 that's rated at 100 GPM, and a class 8, we would only want to run that at 80 GPM. So we wouldn't want to go over 80 GPM just because of the characteristics of the fluid and the design of the meter as well. Viscosity. Viscosity is a property of a fluid that is a measure of its resistance to flow. We need to know the product's viscosity to relate that to a flow rate and find the pressure loss. The pressure loss is very critical when we're sizing a meter because of the bearing plates and the correct, if we're using carbon or metal. And there's different measurements that you may see in some of the specs. SSU, Sabalt Seconds Universal, Centipoise, Centistokes, those are the 3 most popular. The Pascal seconds and millipascal seconds, I see that some, but not as often as the top 3 there. So it's good to always know the product's viscosity. And the concerns, again, with the viscosity is selecting the pressure loss across that meter. The bearing material depends on the pressure loss across the meter. Metal to metal in the class 1 meters, we see that one that has pressure loss allowed at 10 psi. On the carbon metal on the class 10, class 16 meters, it's 8 psi loss across that meter. And in the class 4 Teflon metal, I'm sorry, on Teflon metal in the class 8 meters, it's only 4 psi pressure drop. So it's critical knowing, you know, the bearing material, the viscosity, and all that, because we got to size that meter according to the pressure loss that of the meter. And this chart right here shows you it's on Stoddard solvent, and this is 30 SSU 1 centipoise, which is equivalent pretty much to water. And this chart here at 100%, if you can see it 100% all the way to the right, and you follow that up, you can see that it's a 2.3 psi pressure drop across that meter at at Stoddard solvent at 30 SSU. When operating at 50%, you can see it stops at, it looks at 0.6 psi pressure drop. So the LC meter is relatively has a low pressure drop across the meter. But once we start adding viscosity, that's when we need to use a conversion factor. And this example right here, this chart here, say for instance 1000 SSU. If you follow that up on the left-hand side, you'll see 1000 SSU, and you come across to where it intersects, and it's 3.2 conversion factor. So we need to take that conversion factor and add it to our basic pressure drop across that meter. And this slide here gives those numbers. So for instance, if the meter is operated at 100% of capacity, the pressure drop for safety solvent, or you know, a liquid similar to water, would be 2.3 psi. And if at 1000 SSU, our conversion factor would be 3.2. So we multiply that and we get a 7.36 psi pressure drop. So you can see that adding the viscosity of 1000 SSU increases the pressure drop across the meter. So can we use an M7 meter on lube oil? At 80 GPM at 7000 SSU, we have a pressure drop. We calculated a pressure drop of 9 psi. At 90 GPM, 7000 SSU, we have calculated a pressure drop 11.4 psi. At 80 GPM at 10,000 SSU, we have calculated a pressure drop of 10.5 psi. So can we use an M7? M7 at 80 GPM at 7,000 SSU, we calculated a 9 psi pressure drop. An M15, we have a 2.4 psi pressure drop. So technically, we could use an M7 or an M15 in this application. You know, if the flow rate gets up above 80 or 80, you may want to look at going with the M15 just because of the lower pressure drop. And also system requirements, made it look at other pressure drops in the system as well. At 90 GPM, 7000 SSU, we have 11.4 psi pressure drop on the M7. And for the M15, we have a 3 psi pressure drop. So in this application here, we would need to use an M15 meter. At 80 GPM, at 10,000 SSU.
Sorry to interrupt. I still see you may need to advance the slide regarding the M15.
Okay, you don't see it on the
No.
right? I'm sorry. Okay, yeah, okay. Well, yeah, on the, I'm looking at the M7 and M15 on this screen here, so.
Now we see it.
Yeah, because, yeah, when that next slide is going into seals.
There you go. There you go.
Yeah, at 80 GPM at 10,000 SSU, we've calculated a pressure drop of 10.5 psi. And on the M15, we've calculated 2.8 psi pressure drop. So in this instance here, this application, we would need to use an M15 because the pressure drop across the meter on M7 is too high. Any questions on pressure drop, viscosity? Okay, determining the seal material. Seal material is critical. Buna, we see that, I mean, that's more common in the meters, minus 65 to 250 degrees. Viton, minus 20 to 400. When we get into some higher temperature applications, we'll recommend Viton. The only thing with Viton, if you get down below that minus 20 or you get down to some cold temperatures, Viton may have a tendency to crack or become brittle. PTFE Teflon, minus 400 to 500, a wide temperature range, very chemical compatible with your caustics, your acids, so you may see that more in some of those type of the class 8 meters. EPDM, don't see that as often, but it is available. And pressure recommendations on all M series meters, the pressure rating is 150 psi. On the MSAA with 150 pound flanged added to it on the meter is 275 psi. On the MSA with the 300 pound flange is 300 psi. And on the MA series, which is typically used, you see that one in the LPG pressure rating of 350 psi. And note that all these pressure ratings are based on non-shock working pressures. And temperature recommendations, M series 150 degrees F is good for 150 psi. And as the temperature increases, the pressure decreases recommendation. So at 300 degrees, the rating is only good at 50 psi. So once you increase that temperature, need to make sure that, you know, the pressure rating, need to look at the pressure ratings. The MA series, same thing here, 150 degrees at 350 psi, and as the temperature increases, the pressure rating decreases. And same with the MSAA meter as well. And for the temperatures above 300, we recommend using the steel case meter. Other considerations to look at is, you know, look at the product lubricity. A well lubricated product is going to last longer in the meter. If you get a product that has no lubricity, then we need to look at especially what the carbon inserts instead of metal. You know, if a well lubricated product is going to, the meter's going to last longer if it's a well lubricated product. So just try to find out as much information as you can. The pH hydrogen ion concentration is good for, you know, when we getting into some of the acids and caustics and stuff. Galvanic corrosion, abrasives. If the product is very abrasive, we need to know that. Product that may air harden, temperature harden, may crystallize. For instance, DEF, when it's exposed to air, it can crystallize. So it's good to know any information like that pertaining to the product. And if you look in pages 7 and 8 of the Meters and Accessories book, you will find more information on some of this here. And again, Liquid Controls uses a class system to identify the meter and for its applications. A class 1 meter for metering your refined petroleum products, such as leaded and unleaded gasolines, your fuel oils, your diesel fuel, kerosenes, also used in some of the glycol, used on motor oils. It's aluminum body housing. Class 2 meter for metering aviation gasolines and jet fuels. When meter is installed downstream of the filter separator. Non-ferrous construction, meters may be operated at rated capacity, and also this is an anodized aluminum body. Class 3 meter for metering a wide variety of products, your liquid sugars, your corn syrups, corn sweeteners, shortening, corn oil, soybean oil. And this is aluminum body meter, and the rate of flow is based on the viscosity to pressure loss relationship. So make sure that we know the viscosity of the product that you measure for this one here. Class 4 meters for treated waters, deionized, demineralized water, potable water, certain solvents. And also this meter can be substitute for the former class 16 and 17 applications. And this is an anodized aluminum with stainless steel construction. You see this on some of the windshield washer fluids and such. Class 8 meter for metering your acids and your pH, such as nitric, phosphoric, glacial, acetic acids, some of the fruit juices and vinegars. This is all 316 stainless steel construction. And again, this one here, operation at 80% of maximum rated capacity. So like on an M7 rated for 100 GPM, don't recommend operating this meter over 80 GPM. The class 10 meter for your LPG, liquefied petroleum gases, butane, pentane, ethane, propane. The materials of construction, including the seals, are UL approved for propane. Modifications to the materials of construction may be required for other liquids, including commercial grade anhydrous ammonia, aluminum construction. So this class 10 is rated at 350 PSI. Class 14 meters for your crude oils, number 6 fuel oil, animal fats, also for heated and more viscous products. It's aluminum construction body. The class 16 meter for your general solvents, your methanols, your toluene, alcohols, including ethanol. This meter may be operated at rated capacity except for continuous duty service. So if you're going to run this meter at a continuous duty service, you may want to look at maybe the flow rate, but we can help you with that if you're going to use this meter at a continuous duty service. And this is aluminum construction body as well. Some of the class meters that are no longer available: the class 7, class 27, class 37 and 47, the cast iron meters, the class 20 in brass, and also the class 15 and the class 30 in aluminum is no longer available. But with these obsolete classes of meters, we may be able to look at an LC mass meter offering to replace this in some cases. And that's the end of that presentation. Any questions on this?
Great, thanks, Rick. So yeah, let's go ahead and open this up to any questions. So those of you who stuck around, even though we've gone a little bit over, appreciate that. If you have any questions, please feel free to unmute yourself and ask away.
Don't want to ask questions out loud, feel free to contact your regional manager, and they will be able to assist you with any applications, questions that you have.
I got a question just in general. I know that we have that you guys are recording these. Do we have access to those recordings for later reference?
If you have
Yes.
registered, which you have since you're able to get allowed, yes, they're available. The presentations a few days after they're presented, they're available on our website. Okay. Under resources, isn't that right, Jeff?
Correct. So once you you should when either you got an email from us if you signed up early to the classes, or if you're just a recent attendee, you should have gotten an automatically generated message, basically giving you an invite to the LC University portal. Once you're on that portal, as the videos become available, they'll be there where you can click on the link. So the first 2 classes that we did last month are already up there and available. And this one, we'll probably need a couple days just to quick edit, and then we'll get that one up there as well.
Okay.
Thanks, John.
Sure.
And so, like Kevin said, we'll be sticking around here for a little bit to address any questions. But again, that kind of concludes this presentation. Don't forget, next week, I'm sorry, not next week, in 2 weeks, again, on Wednesday morning, will be the next presentation from our regional managers, and that will be on an introduction to our electronic registration. So please feel free to join us for that. If you don't have any questions, you're free to jump off the call, but we'll stick around here for a little bit to address any remaining questions that anybody may have. And like Kevin said, if you're not comfortable in this environment, please reach out to your regional manager or our technical support department. Thank you.
Thanks for joining us, everybody.
Yeah, thanks again. Sorry for the technical difficulties, but I know it went over a little bit, but we were able to get it done, but I know it went over, but appreciate everybody being patient.
Thanks, guys.